Hello everyone, here is our review of the polynomial unit, and this is going to be a quite lengthy video because we're going to review all the different concepts we have looked at in the polynomial unit. But this is a video where you really just want to use what you need, right, for your review. And so I suggest that you fast forward and kind of just pick and choose what it is you really need to review. Alright, so the first thing we had looked at was the analysis of polynomial graphs, sorry, I can't talk, and curve sketching. So we are given a graph here, and what we have to find are the zeros and their multiplicities. So when we're looking at this graph, there is a 0 right there at -3. So we're going to have x equals -3. Remember, we're always putting the variable along with the number, right? We don't just say -3. So x equals -3, and if we're looking at this graph is concave down and switches to concave up. So if you recall, this will be a multiplicity of 3. And then the next 0 is right there at x equals 1. And this one intersects the x-axis by going straight through, right? There is no concavity change, so there is no multiplicity of this, so that will just be one time, right? You can say 1, but... And I'm writing 1 for a purpose, because now I'm going to say, okay, I need the degree of this polynomial, so now I can just add all my multiplicities, and that gives me the degree. But to do that, I needed to have the x equals 1 showing that it's there once. So the degree will be 3 plus 1, so it's a fourth degree. But we need to specify the type of the polynomial, so we know a fourth degree is a quartic. And then we need to give the sign of the leading coefficient. Well, look at your graph. The right-hand side of the graph goes down to -infinity, and therefore our leading coefficient is negative, because the behavior on the right-hand side goes to -infinity, right? And then a possible equation for the function, and remember it's going to be a possible one because we don't know anything about a vertical stretch or compression. See, there is no scale on the y-axis. So a possible equation, I'm going to call this, we're not given a name, so I'm just going to call it y. And you have to say y equal because it says they want an equation, right? So y equals, I know I'm going to have x equals -3. The factor, when I move that across, would then be x plus 3, and I would have that 3 times. And then x equals 1 as a factor becomes x minus 1, and I have it only 1. So that would be my equation, or a possible one, right? Next graph here. So we have one root here at -2, and the graph goes straight through the x-axis. There is no change in concavity, no U-turn, anything. So x equals -2. And again, for a minute, when I need to find my degree, I'm going to say I have this one once, right? And then here, x equals 1 is another 0. But at this one, the graph is tangent to the x-axis, right? It does that U-turn, so that's an even multiplicity of 2. And now the degree, just add your multiplicity, so it's a third degree. And a third degree specifically is called a cubic. Sign of my leading coefficient, the right-hand side goes down to -infinity, therefore the leading coefficient is negative. And now a possible equation, so remember we need an equation, so I need an equal sign. Y equals, and I'm just going to use my zeros, right? So x equals -2 becomes x plus 2 as a factor. Multiplicity of 1, so no exponent, and this one becomes x minus 1 with a multiplicity of 2. Alright, now we're given a table of values, and we have a few things to answer, but now let's first check, do we have any information? We are just told it's a polynomial. The zeros in the table are the only zeros of the function, so we know that whatever we see here is what we get. And no zeros have multiplicity greater than 2. So they could have 2, but nothing more than that. and then we need to answer the questions. Okay. Identify the left and right hand behaviors of the function g of x. So the left hand behavior, it looks like my graph goes from 3 point something to 360. So it looks like it's shooting up to infinity, right? So the left hand behavior, I'm going to say as x approaches negative infinity, right? As my x move along the x-axis toward the left, toward negative infinity, g of x, which is the name of my function, right, seems to be approaching positive infinity, right? The numbers are getting huge. And then on the other side, as my x's are going to get positive greater and greater, my y value seems to be shooting up to positive infinity also, right? So we're going to say as x approaches positive infinity, my g of x seems to be approaching positive infinity also. Well, now we already know one thing, right? Both behaviors are going in the same direction, so we know we have what kind of degree. We know the degree is even, so we have an even degree because the n behaviors are alike. And the leading coefficient, what do we know about the leading coefficient? Well, the right-hand side seems to be going up to positive infinity. Therefore, the leading coefficient is positive because g of x goes to positive infinity as x goes to positive infinity. So as we're moving towards the right is what that means, right? G of x is going to positive infinity, so the leading coefficient has to be positive. All right? So we answered the question and we explained, right? Identify the zeros and their multiplicity, justify your answer, okay? We are told, remember, that all the zeros are in the table. That's what they're telling us. So I'm looking for all my y of zeros. So there is one here, there is one here, there is one here. Those are the only one I have, but I know that my degree has to be even. So I cannot just have 3 x-intercepts, right? So now we're going to look. So my zeros are going to be x equals negative 3, x equals negative 1, and x equals 2, right? Those are my zeros. On either side of these zeros, my y values are positive and positive. That means that my graph, if my y values go to 0 and are positive again, it means my graph is tangent to the x-axis. This 0 has a multiplicity of 2. This 0, the y's are positive on the left and they switch to negative. So this one, the graph would actually come from above and go down, right? So that's just one. I did a curve there and I didn't mean to. I'm actually going to just erase that. And then this one goes from a negative through 0 to a positive. So it goes also straight through. So no more multiplicity. So we know that x equals negative 3 has a multiplicity of 2 because, we have to explain, right? Because the y values on either side of x equals negative 3 are positive. And I'm just going to say like that, positive. And because they have the same side, we know we need a U-turn there. All right, moving on. First page done. Woohoo! Now we're going to analyze and sketch. So we have to do a little bit of analysis first. So we're given a cubic, so we know we're looking for how many zeros? 3. They don't all have to be real though, right? And we can't graph like that, so we have to factor that first. So we're going to say f of x is equal to, I'm looking for what is common in all my terms, and they all have a factor of negative 2 and x. So negative 2x comes out, and then what's left over? If you factor out negative 2x here, you're left with x squared. Here you would be left with 4x and 4. And now we have a quadratic, so look and factor that again, right? So that would be f of x equals negative 2x. No number in the front, what can I multiply to give me a 4? Add up to give me a 4, that would be 2 and 2. So I have x plus 2, but we don't write those like that, right? Those are the same. So we're going to say x plus 2 squared. Okay, that's the factored form. So what are my zeros? I have 1 here, that would be x equals 0, right? Because negative 2x equals 0, divided by negative 2x equals 0, right? So that's my first one. There is no exponent, so no multiplicity. And then my next one will be x equals negative 2, but I have a multiplicity of 2. What's my leading coefficient? Well, the leading coefficient is negative, and the degree is odd, right? The degree is 3, so it's an odd degree. So what does those two tell me about my n behaviors? Leading coefficient is negative, I know the right hand side has to go down. The degree is odd, I know they have to behave, or they're at odd with each other, right? Opposite directions. Okay, so this graph is going to go up here, down here, and I need to go through x equals 0 and x equals negative 2, but here I'm going to be tangent, right? So coming from up there, tangent and through. That's the sketch of the graph. The next one is given to me already in factored form, so that's kind of nice, but I need to figure out, so first of all, what are my zeros? Since it's in factored form, it will be quick. X is equal to 3 for that factor, and x is equal to 1 for this one, but this one has a multiplicity of 3. It's an odd multiplicity, we know we're going to change concavity on that, right? My leading coefficient, well, I need to check. This is an x, this is an x which is going to be cubed. So x cubed times x, that's still going to be a positive x to the 4th. So it will be positive. And then what is the degree? The degree will be 3 plus 1 is 4, so the degree is even. So knowing that, I know my n behaviors are going to be leading coefficient goes positive infinity, and the degree is even, so they have to behave evenly. So I need to go to infinity on both sides of my graph. I need to hit x equals 3 straight through, and at x equals 1 I need to have a multiplicity of 3, so a change of concavity. So I'm going to come from up here, concave up, switch to concave down, and now go back up to hit this one. And this is a sketch. Remember, we're sketching, right? They're not precise, but they're sketches. Next one, so this one, the zeros, x equals negative 1, x is equal to 1, and x is equal to, here we have to be careful, right? You see how 3 minus x equals 0? So when you add x to both sides, you get 3 equals x, right? So be careful when they're inverted like that, when they're switched. So x is 3. There is no multiplicity, none of them has an exponent. So I'm going to have a 0 at negative 1, at 1, and at 3. What is my leading coefficient? Attention, attention. We don't have a multiplicity, but when I multiply a positive x times a positive x times a negative x, see, when they're switched, you have to be careful. That will give me a negative x cubed as a first term. So my leading coefficient is negative. The degree, well, if I will get a negative x cubed as my leading, that would be an odd then, right? And so what does that tell me about my n behavior? The right hand side goes to negative infinity, and they're at odd with each other. So we're going to go down here and up there on that end. We're going through all of those, no multiplicity anywhere, so just straight through everywhere. Straight through and straight through. There we go. All right, Long division, do you remember? So we're going to long divide this polynomial by this one, and then we're going to have to rewrite that quartic polynomial in factored form. So let's do our long division first. We check, right? This is a quartic, so we have the quartic, the cubic, the quadratic, the linear, and the constant, so we don't need any zero placeholders. So we're going to write them all down. Remember, here we need everything, right? That's not synthetic division, so we need the coefficients and their variables. And we're going to divide all of that by this trinomial, so x squared minus x minus 2. Okay? We're going to use the first over the first, so 6x to the fourth divided by x squared is 6x squared, so above the quadratic term. And now we multiply. 6x squared times negative x is a negative 6x cubed, and 6x squared times negative 2 is negative 12x squared. At this point, we're subtracting, so change here, here, and here. That goes to 0. 11 plus 6 is 17x cubed. And negative 24 plus 12 will be negative 12x squared. Bring the next one down. And if you want to, you can bring them all down. Doesn't matter. And then we go next, divided by this one. So 17x cubed divided by x squared is just going to be a 17x. It's a linear, so above the linear term. And it's a positive 17, so plus. Now we multiply. So that will give me 17x cubed. 17x times negative will be negative 17x squared. And 17x times negative 2 will be negative 34x. Now we are ready to subtract. So change the sign, change the sign, change the sign. Those cancel. Negative 12 plus 17 will be 5x squared. That will be a negative 5x, and bring the next one down. Okay, almost there. 5x squared divided by x squared will give you a positive 5. So above the constant term, we're going to have plus 5, and now we multiply. 5 times negative x will be negative 5x. 5 times negative 2 will be negative 10. And when I'm going to subtract those, change all the signs, they all cancel, the remainder is 0. So this is actually a factor of my polynomial, which is going to be really cool because now I can write it in factored form, right? Okay, so what do we have? We have that f of x is going to be equal to this times the divisor plus the remainder, but we don't have one, right? So we're going to have 6x squared plus 17x plus 5 times the divisor x squared minus x minus 2, and then it will be plus 0, but we don't put that down. Now we have to rewrite this in factored form, so the first thing you have to ask yourself, are those factorable again? And in fact they are. This one is actually going to become, what can you multiply to give you a negative 2 and add up to give you a negative 1? That would be a negative 2 and a positive 1, right? So when you multiply those two, you get negative 2. When you add x and negative 2x, you get negative x. And now how about this one? Well, you're going to look for 6 times 5 is 30. And so what can we multiply to give us a 30 and add up to give us a 17? Well, that's kind of easy, isn't it? 15 times 2. So we want that. And then you're going to do your grouping. So I'm going to do that a little bit on the side if you still need to do that. So 6x squared plus 15x plus 2x, right? I'm using 15 and 2 to replace the 17. And then my plus 5 there. And then I do my grouping. So that will be factor out of 3x, be 2x plus 5. And this here is already 2x plus 5, which is what I want. They have nothing in common, so I just factor out a 1. And so one of my factor will be 2x plus 5, and the other one will be 3x plus 1. And this is my f of x written in factored form. Alright? Now we're going to use Pascal's triangle to expand. So we're really jumping. So we're going to say, okay, Pascal's triangle is a triangle of ones. And now I'm adding those two, put my ones to keep the triangle shape. Add those, put the ones to keep the triangle shape. 4, 6, 4, 1. I need one more row because my exponent is a 5, so I need a 5 next to the 1, right? So 1 plus 4 is 5, 10, 10, 5, 1, and 1. And that's the line, the row I'm going to use, right? So I'm going to have a 1, a 5, a 10, a 10, a 5, and a 1, multiplied by the first term in the binomial, so 2x, and we are going to have all of those multiplied by 2x. I'm going to start with the 5, right? So to the 5th, and counting down, 4, 3, 2, 1, 0. Then I need my next term in the binomial, and don't forget that sign there, so that's a negative 1. So now all of those are going to be multiplied by a negative 1. Here I'm starting from 0 and I'm counting up to that exponent. So 0, 1, 2, 3, 4, and 5. Anything to the 0 power just goes to 1. So those are going to 1. 2 to the 5th is 32. So this here is going to be equal to 32x to the 5th. Then we have 2. So here I have 5 times 2 to the 4th is 16, x to the 4th, and then negative 1 times 1 is just a negative 1. Multiply all of that together, so what will that be? So that will be 80, right, and a negative. So negative 80 x to the 4th. Alright, so this is going to be a 10. 2 cubed is 8. So times 8, x cubed. Negative 1 squared is just going to be a 1. So that will be an 80x cubed. Now we have 10. 2 squared is 4x squared. And negative 1 cubed is a negative 1. So that will be 40 times negative is negative 40x squared. Then I have 5 times 2 to the 1st is just 2x, and then negative 1 to the 4th is just a times 1, so that will just be 10x. And finally, we have a 1 times a negative 1 to the 5th power, which is just a negative 1. So now we need to say what that is, right? So let's expand that. Let's put an equal sign here, and let's just write all our numbers down. So what would that be equal to? 32x to the 5th minus 80x to the 4th plus 80 x cubed minus 40x squared plus 10x, and finally minus 1. So that will be this expanded. Now we're going to use the binomial theorem, but we're not going to expand completely. This is kind of a favorite type of question for EOC purposes here. They're going to say, well, which term is going to end up with an xy cubed when you expand that? So you have to ask yourself, x is going to be to the 4th power first, right? And y is going to be to the 0 power. So kind of on the side, I'm going to say, well, my combinations, I'm using the binomial theorem here, so the combination, right? the exponent is 4, 0, 4, 1, 4, 2, 4, 3, 4, 4, right? But those would also be the exponent of my variables, right? So I'm looking for an x to the first power and a y cubed. So I'm looking for this one right there. I want my y to be cubed. And when you subtract 4 and 3, the x will be to the first power then. So I'm looking for this one, and I want that times x to the first power, right? This one will be 4, 3, 2, 1 for the x, right? And then times the next term will be that whole term, right? So the negative 3y will then be to the fourth power. When you add those two exponents, oh, sorry, not the fourth. I'm glad I just said that. The third. When you add those two exponents, you need to get back to that 4, right? And that matches. And that 3 has to match up here. So what is that term? Well, what is the combination 4, 3? We know what it will be, right? But just to remember how to review how to do it on the calculator, we're going to go menu. We're going to go probability number 5 and number 3 for combination. And then I'm going to put in 4, 3. So 4, is way down there, 3, and it's going to give me a 4, right? So we knew that, but still. 4 times, so that's just the number given by this combination. And then it's an x to the first power. And what is negative 3 cubed? Well, that would be negative 27 and then y cubed. So now to finish that, I would have to do 4 times negative 27. So we're going to do 4 times negative 27, which is negative 108, x, y cubed. So we use the binomial theorem, meaning we had the combination, to find the term. So we want the whole term right there. Okay. Now we're going to go to our identities and to our factoring business. So here I'm looking and I said, that doesn't fit any of my identities, but do I have a common factor? And in fact I do, right? There is a factor of 2 in both of those. So I'm going to take out a 2, and that will be 27 minus 8x cubed. So then I recognize this as being a difference of perfect cubes, so that will factor, right, in a binomial and in a trinomial. So the cube root of 27 is 3. The sign, the first one keeps the sign here, and those two then are going to both be pluses. And the cube root of 8x cubed will be 2x. Now take the first here and square it. Take the second here. No, sorry, multiply them with each other. What am I doing? The 2 times 3 is 6x. And now take this one and square it. All of that is equal to 0. Now we're not done, right? Because it says solve by factoring. So now we have to keep going. We have one factor here, so that will be 3 minus 2x equals 0. This 2 does not have a variable, so we don't have to worry about it, right? Because we're solving for x. We know 2 is 2. There is no mystery there. So we're going to add 2x, and we divide by 2. So 3 over 2 equals x. That's my first solution. This was a cubic. I need 2 more, right? And so now I'm going to look at this one. And I know when I do a sum of perfect cubed, I know this one's not factoring. So I'm going to have to do a quadratic formula. So it's going to help us review that at the same time. Be careful. This is your a value. This is your b value. This is your c value. Don't let that trick you because it was not written in standard form, right? Okay, so we're going to have negative b, so negative 6, plus or minus the square root of b squared, so that's a 6 squared, minus 4 times a, which is your 4, times c, which is 9, all over 2 times a, which is 4. Alright, we're going to let the calculator help us to go quicker here. And so we're going to have a 6 squared for the discriminant, minus 4 times 9, and my discriminant would be negative 108. So negative 6 plus or minus the square root of negative 108 divided by 8. The square root of 108 is going to be, you can factor that again, right? So a quick review, you go menu, numbers, if you're not sure, right, how to factor that. And then you go 3 for factor, and you're going to type in 108, and it's going to give you the prime factorization of 108. And now you can see that you have a 2 squared and a 3 cubed. So 2 squared, 3 squared, and 3, right? That's your 3 cubed. That's your prime factor there that you can, sorry, not your prime, your perfect square. So that will be 36, right? So x equals negative 6, and then we have plus or minus. If this here is 36 times 3, right? This is 36 and that's 3. So if that's 36 times 3, the 36 will come out as a 6 from the square root. The negative will come out as an I, and then the square root of 3 stays over 8. But now we can simplify those, right? So we're going to go back here and we're going to say the next two solutions will be x equals negative 6 over 8 will be negative 3 over 4. And then 6 over 8 will be 3 over 4. So plus or minus 3i square root of 3 over 4. And so those are your solutions. Keep solving by factoring, but this time is a grouping one. So we have 4 terms. We can see what they have in common 2 by 2. So those two have only x squared in common. And so when I factor out an x squared, I'm left with 2x minus 3. Those two have 4 in common. And when I factor out a 4, I would get negative 2 plus 3, but I want the opposite of that, right? So I'm going to factor out a negative 4, and so that becomes 2x minus 3. And now they're matching, they're being the binomials. So because I have that in both of my terms, I can factor it out, and I'm left with x squared minus 4. Don't stop here, you still know the difference of perfect square, right? So that goes to x plus 2, x minus 2, the two conjugates. And now we can use the zero product property and say, okay, then x is equal to 3 over 2, negative 2, and positive 2, so plus or minus 2. We have 3 solutions. It was a cubic. We are good to go. Keep solving by factoring. First off, we say, that's not equal to 0, so let's just set that equal to 0 first. Once that's done, we say, oh, they all have at least a factor of x, so we can factor out an x. Oh, what am I doing? What am I doing? In my head, I was thinking, oh, that's a nice quadratic, and I wrote a quadratic, didn't I? All my exponents are even, so that's what I was thinking in my head. I said, oh, that's kind of nice, right? So I can factor that like I would a quadratic. But in each of my binomial, instead of having an x, I'm going to have an x squared. So what can I multiply to give me a negative 9, but add up to give me a positive 8? That would be a plus 9 and a minus 1, right? Multiply those two will give you negative 9. Add them will give you the positive 8. But we know that's a sum of perfect squares, and we're solving by factoring. So I can factor that into my complex conjugates as x plus 3i and x minus 3i. And this is a difference of perfect squares, so that's x plus 1 and x minus 1. Now it's completely factored, and I can just go ahead and solve. This first x is just going to be x equals 0. Those two are going to give me plus or minus 3i, and those two are going to give me plus or minus 1. Count your zeros to make sure. We have 2, 4, 5, quintic. We're good to go. Alright, now we're going to go more into the meat of all of that. The equation of the cubic is given to us, but there is a k value in there, So I hope you recognize that. And we are told that f of 2 equals 0. So we need to first determine the end behaviors of the graph. Well, the leading coefficient, and we justify, right? So we're going to write down as we go our thinking. Leading coefficient is negative. So we know that the right-hand side goes down to infinity. And then the degree is odd. So we know they have to be at odd with each other. So as I wrote that down, I justified why this should be my end behaviors, right? Now, technically, we should write that as x approaches negative infinity, f of x approaches, so as I'm going to the left, we're going to positive infinity, and as x approaches positive infinity, which means the right, f of x is approaching negative infinity. So technically, formally, that's how we write it, right? What is the y-intercept of the graph? And then explain. The y-intercept is always where all your x's are going to be equal to 0, right? Because if you're thinking about a graph, the y-intercept is going to be where x is 0. So we're going to replace all those x in that function by 0. And when you do that, you're going to get a 0. So we have to explain, right? So I have to write it down. So the y-intercept is where f of 0 is. So that would be negative 2, 0 cubed plus 2, 0 squared plus k times 0 plus 4. The y-intercept is always the constant, right? Because if you replace all your x's by 0, anything that's left will just be the constant. So we knew that, but we had to justify and explain. So the y-intercept will be 4. Or you can write it as an ordered pair with your x equals 0. And we knew that, right? F of x is divided by the factor x minus 2. What will the remainder be? Now, they're not telling us to divide. They're saying if it is divided by x minus 2, what is the remainder? Well, this is the remainder theorem, right? And it's going to tell you, we know that f of 2 equals 0. If f of 2 is equal to 0, then, so we're going to say because it is given that f of 2 equals 0, then by the remainder theorem, f of x divided by x minus 2 has a remainder of 0, right? It has to be equal to the function value for that factor. That's what the theorem tells us. Find the value of k in the equation. So now we're having that, and we need to find what k is. So we already know that if we will divide by x minus 2, we'll get a remainder of 0. So we're going to use that fact. So we're going to set it up. Cubic, quadratic, linear, constant. So I need a negative 2, a 2, that k, and 4. In my box, I'm going to put in that x value of 2 because I know that this x value of 2 gives me a remainder of 0, according to the remainder theorem. So now I'm going to do my synthetic division. That will be negative 4, negative 2, negative 4. Add those will be k minus 4. Multiply that, and that will give you 2k minus 8, right? And then you know that to do 4 plus something to get 0, well, let's just write it down. 4 plus 2k minus 8 equals 0. So that will be 2k minus 4 equals 0. Therefore, 2k equals 4 and k is equal to 2. Okay. We need to find all the roots of f of x. Well, we already know that 2 is a root because we get a remainder of 0, right? So we know that. So I'm going to say x equals 2. That's one of them. That's a given. Now, I know that k is 2, and when I divide it by x equals, for, sorry, but x minus 2, I got this right there. So let's just do it this way. Let's just replace that k by what we know. So negative 2, 2, we know k is 2. Oh, that's a whole bunch of 2's. And then 4, and we're going to divide that by 2, because we already know that's a 0. We already know we get the remainder there. Right, okay. So what would that be? No x, x squared. So negative 2x squared minus 2x minus 2. And I want to find all my roots, so I have a factor of negative 2 that's common to all my terms. So I'm going to factor it out. And now what can I multiply to give me a 1 and add up to give me a 1? Well, there is nothing, right? Oh, you don't see that, do you? My apology. There is nothing, right? So I'm going to have to do a quadratic formula or completing the square. So negative b plus or minus the square root of b squared minus 4 times a, which is a 1, times c, which is a 1, all over 2 times a. This here is negative 4, and so 1 minus 4 will give me plus or minus the square root of negative 3 all over 2. This here comes out as an I, and the square root of 3 cannot simplify, so that will be negative 1 over 2, and then the plus or minus I square root of 3 over 2. So I have this solution, and I have x equals negative 1/2 plus or minus I square root of 3 over 2. Two solutions here, one here. We're good to go. Find all the complex root of this quartic. So if I need to find all the complex root, I need to do the factor theorem, remember? So we need the factors of negative 12 over the factors of 6. So negative 12 will be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And all of that would have to be over plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now, we don't want to spend all day here doing that, so I'm going to use my graphing calculator to help me out here a little bit. I'm going to open a graph page, and I'm actually going to graph this polynomial to see if I can figure out any of those real zeros, right? If any. Hopefully we have at least one real zero. Okay, always double check that you typed in right, because otherwise looking for something that's not what you want. And when I'm looking at this graph, whoa, they're not nice roots, are they? But it looks like I have a root toward 1.5, so that would be like 3 over 2. Do you see how I decide that? It's not on any integer, but it's between 1 and 2. And it looks like 3/2 will be one of my solutions. So I'm going to test 3/2. So I'm going to say, okay, I want 3 over 2 in my box. And then I'm going to do my synthetic division. I didn't check if I had them all, but I think I did, right? Quartic, cubic, quadratic. No, I missed something. Quartic, cubic, quadratic. I need another negative 1 for linear, and then my negative 12. Okay, gotta check that. Bring down the 6. Okay, so that will be 9, right? 6 divided by 2 is 3. 3 times 3 is 9. That will be 8. 8 divided by 2 is 4. 4 times 3 is 12. That will be 11. Oh, that's going to be ugly now. So we're going to have an 11. We're going to have an 11 over, so that would be 33 over 2. And then we're going to subtract 1 from that, so that's a negative 2 over 2, right? And so when you're subtracting, that will give you 31 over 2. And then when you're going to multiply that, oh, that's just too ugly. Just too ugly. Alright, so we're going to multiply that. That will give you a 93 over 4. And that's not possible, so I messed up somewhere. 6, negative 1, or negative 6. There is my troublemaker. You would have been here live with me. You would have stopped me, wouldn't you? You would have said, "No, Miss Williams, what are you doing?" Alright, let's try that again. Hopefully that'll be nicer. See, it happens to all of us, right? So don't feel bad when you make a mistake. Just keep going. 8 over 2 is 4. 4 times 3 is 12. Whoa, that's nicer now, right? So now we're going to have 6. And then we know that 6 divided by 2 is 3. Times 3 is 9. That will be 8. And we know that 8 divided by 4, 12. And that will be a 0. Okay, we're good. No x squared, x cubed. So I have 6x cubed plus 8x squared plus 6x plus 8. Look at that. Isn't that nice? Look at that. All of that equal to 0. We're going to solve by grouping. So we're going to say, take out an x squared. We're left with 6x plus 8. Actually, I can take out a 2 from everywhere too, can't I? Let's do that later. So, no, let's do it now. So let's take a 2 out first. So then we'll have 3x cubed plus 4x squared plus 3x plus 4. And now we do grouping with those. So we have still that 2 in the front, but now we have take out an x squared, so we have 3x plus 4. And here we can't take anything out, so it's just going to be a plus 1 and 3x plus 4. And we have that 2 in the very front. We have x squared plus 1 and the 3x plus 4 equals 0. And so I know this here is going to factor into my complex conjugate as an x plus I and an x minus I, and this one just stays 3x plus 4. I don't need that 2 anymore, but I'm going to put it there. So we already had 1 0 given to us there, right? So we're going to put this one down so we don't lose it. So we have a 3/2. This here will be equal to a negative 4/3, right? And then those two will be positive or negative I. Count. 2, 3, 4. It was a quartic. We got them all. Alright, we have 2 problems to do, but I don't have too many minutes left. I need to be below an hour here. So we're going to find all the complex roots. I'm going to let you go ahead and play with this one. It's similar to the one we just did, right? So go ahead and do this one, and I'm going to focus on that last one. So we have h of x with a root of x plus 1 multiplicity of 2. So we already know something. If x plus 1 has multiplicity of 2, we know x minus 1 squared is a factor. And then we're told that x equals 3 plus I is also a root, but then we know because of the conjugate root theorem that we need to have the conjugate of that also, because that's a complex root and they come in pairs. So now I'm going to say, okay, then I'm going to have x minus 3 minus I and x minus 3 plus I. And then I'm going to use what I know about my identities. And I'm going to say, This is something minus I, that same something plus I. Those are two conjugates, right? So when I multiply them, when you multiply two conjugates, A plus B, A minus B, that's just going to give you A squared minus B squared, right? But if your conjugates are complex, if you recall, then that's going to become A squared plus B squared, right? So knowing that, I'm going to go quick here. I'm going to say, okay, I want that squared, so x minus 3 squared, and then plus whatever is in front of the I squared, and in front of I it's just a 1, so 1 squared is just a 1. And then multiply by that. I'm going to go ahead and expand that. So x minus 1 squared is x squared minus 2x plus 1. And now I need to expand this one, so that will be x squared minus 6x plus 9, and then plus 1, that will be plus 10. I need to multiply by that. And here I'm just going to do the vertical method, because it looks like those are nice, two nice trinomials with no missing terms. So I'm going to do the vertical method. The same method you used in 3rd grade when you started to multiply numbers with more than one digit. So 10 times 1 is 10. That's a negative 20x. 10 times x squared is just going to be 10x squared. Then I have negative 6x times 1, which is negative 6x. Negative 6x times negative 2 is a positive 12, and x times x is x squared. And that's negative 6x cubed. And then I'm going to have x squared times 1, which is x squared. X squared times negative 2x is negative 2x cubed. And then x squared times x squared is x to the 4th. And now I'm just going to, oh, I'm getting really crooked here. I'm just going to add all my like terms, right? So an x to the 4th. Negative, negative, that's a negative 8x cubed. 10, 12 is 22, plus 1 is 23, so plus 23x to the 2nd. That would be negative 26x plus 10. And that, ladies and gentlemen, is my h of x function. And we are done! Yay! Go study for this test now.